Hello everyone, welcome to Learn Data Structures and Algorithm in Python course. In today's lecture, we'll be solving another problems on greedy. Let's see what is the problem. So this is called minimum platforms. Let's say you are standing in a station, right? And trains have some arrival time and some departure times. So these are basically arrival times like 9, 9:40, 9:50, 11, right? And some departure time. Okay. Now here you have to tell how many platforms, how many minimum number of platforms are required so that you can arrange all the trains. So you have to tell basically minimum number of platform you require to arrange all the trains. That is the problem. So let's say you have an arrival array. Okay, let's say one train is coming at 9 a.m. Okay, 9 a.m. and departure time is 9:10. Okay, so for that how many platforms are required? One platform. Okay, one platform. Okay, then the next train is coming at 9:40, right? Arrival time is 9:40. Now if it comes 9:40, and the first train will depart it at 9:10, right? Means whichever platform this train require, that will be empty because it will be departed at 9:10. That means we can place this train in this platform, right? Because departure time of this train is less than this. So what are you gonna do? So first it will come at 9 a.m. and 9 a.m. and it will depart it at 9:10. Okay, so we have no train in the platform. Okay, then what we'll do? We'll put this again, this 9:40. Okay, so till now number of platform required is 1. Okay, now at 9:40 what are you going to do? So let's put some platform here, let's draw some platform here. Okay, so let's say first comes in 9, okay, and it will depart it at 9:10. Okay, that means that train has gone. Okay, that train has gone. Now next thing, the next train will come at 9:40. So when this 9:40 this train will come, so the train says this is platform is empty, right? So it will it will stays there. Okay, it will record this platform. And what is the departure time? It will depart it at 12. Okay, it will depart it at 12. Now what is the next train? Next train come at 9:50. So when the next train at comes 9:50, so it will say that there already train is in this platform, right? Already a train is in this platform because departure of time of this platform is 12, right? So what will do? It will assign a new platform. That means we'll assign this platform for this train. So 9:50. Okay, 9:50. Okay, done. Then what is the departure time? It will be departed at 11:20. So 11:20. Okay, let's say 11:20. Okay, done. So currently how many platforms are there? Two platform required, right? Now what is the next train? Next train coming at 11. Okay, when this train comes, so it will says, so is this platform empty? No, right? Because this train will depart at 12, this train will depart at 11:30. So what it will do? It will assign a new platform. Okay, at 11. And what is the departure time? 11:20. Not 11:30. Okay, 11:30. Okay, that is done. Okay, then the next train comes. When comes? At 3 p.m., right? At 3 p.m. So when 3 p.m., when at 3 p.m. a train comes, so what it says? This train departed at 12, right? So then we can remove this. That means this platform is empty. Okay, this train has departed at 11:30, right? So this platform is also empty. So this train also departed at 11:30, right? So currently okay, previously it was basically 3, so it was 3 platform. Okay, now if when a train comes at 3 p.m, so it says all the platforms are empty, so it will put inside this. Okay, will place inside this. And what is the departure time? It will depart at 7. Okay, 7. Okay, then the next train comes at 6 p.m, right? At 6 p.m, at 6, at 6. Okay, when it comes at 6, so what it will say? It will see that this train will depart it at 7, right? This train will depart it at 7, so it can't place here, so it will assign a new platform for this train. Okay, 6. And what is departure time? 8. Okay, departure time at 8. So how many platforms for this is required? 2, right? So from this, what is the maximum? Maximum is 3, right? Maximum is 3. right? And what happens after 8? So at 7, this train will gone, this train will gone, okay, and also this train will gone, this train will be departed, right? So then what happens? What happens? All the platforms are empty. But how many? What is the maximum number of platform required here? Result is 3, right? Result is 3. Now how, let's see how we can do that, how to do that. So first thing what we will do, when we think about greedy, most of the time we have to sorted this thing in ascending order or descending order. This is the first step. This is the first step. So what we will do, what we when why we are sorting, because we are sorting so that we can get when what train is coming, right? That's why we'll be sorting. So first thing will be sorted this array, sorted this array, as this array is in a sorted manner, right? So we'll not do anything. So if we sort this one, so it will be like 9 10, then 11 20, then 11 30, okay, then 12, then 19 00 200, okay, 200. Oh, this is done. Then we'll take a count variable or number of platform, whatever you want. So let's take a variable as p, okay, number of platform requests. Now we assume that first train has arrived, and for the first train how many platforms are required? One, right? How many platforms are required? One, right? So we'll take a variable p and initialize with 1, okay. Then what is the next thing? We'll take two pointers, one is I, one is j. So we'll take two pointers, one is I, one is j, one is j. And initially I will be, so I is for arrival array and j is for departure array, okay, this two pointer. And initialized I with 1 will starting from the next train, okay. So first we have assumed this train has arrived, okay, and departure time is 9 10, okay. And so that we will be take two pointer, I will be initialized at 1, and departure time we take this pointer j as 0, right? J as 0. Now what we will do, so let's say I want to place this train, in this platform, in this platform. Can I do? Can I do? Can I do? Now to do that, what we have to do, we have to check. Is this departure time? Is less than this one? That means if the train departed at 9 10, that means this platform will be empty. Then we can place this train in this platform, right? So what I mean to say, let's write the conditions. Okay. So our first condition, what is the first condition? If departure of j, okay, this departure of j is less than error of I, okay, means if departure time is less, then what we'll do, we'll just decrement our platform, by 1, okay. Means, so when we see this time departure time is less than arrival time, that means this platform is empty, that train has gone, right? This platform will empty. Then what we'll do, we'll move our j pointer from here to here, okay, from here to here. So what we'll do, first we'll decrement by 1, then we'll move our j pointer, j plus equals to 1, okay. And the next thing, second thing, okay, second condition, what is the second condition? Now let's assume for this one, okay, for this one, okay. Now if we, okay, let's understand through one by one, okay. So now j has moved to, so j has moved from here to not this one, okay. Okay, now j has moved from here to here, okay. Now j is here, okay. Now what we have done, we have empty the platform, okay, we have decremented the platform, so it will become 0, okay. Then when j is at here, so what we'll do, we'll again compare arrival time with departure time. Now if departure time is greater than arrival time, then what we'll do, that means, so if let's say the departure time here is, in spite of 9 10, let's say it is 10 10, Okay, it is 10 10. That means we can't assign a train in this platform because departure time is greater than this, right? Then what we'll do, we'll assign again one platform for this, right? So that's what we are doing this. That's what we will be doing here. So it is 9 10. Okay, now we'll compare these two values. We'll compare this two value, error of I with error of j. Now error of j is greater, error of j is greater. That means we have to, so this is basically else condition. So else condition, so that means else condition means when departure of j is greater than equal to error of I, right? Means departure time is greater than error of I. That means we have to require a new platform. So then what we'll do, we'll increment the platform by 1. Previously we are decrementing the platform, right? We have to empty the platform, and we'll move our I pointer, I plus equals to 1, I plus equals to 1, and we'll be doing this two operation until I is out of bound or j is out of bound, right? I is out of bound or j is out of bound. That is simple. Okay, and every time when we update the p, we'll take a answer variable, and every time we'll be updating this answer variable with max, with max. Let's see one by one. Okay, and now let's say I is here 1, j is here 1. Okay, now we'll compare, is this, so is this j is less than this? No, right? That means what are we gonna do? So we'll increment the p by 1, increment the p by 1, and we'll move our, so this condition, we'll move our I by 1. So I'll be from here to here. Okay, this will be our I. Okay, now again we'll compare this to value. Now is this value, is less than this? Is this value, is less than this? No, right? No, right? So then what we'll do, we'll increment this by 1 again. So now two platforms are required, two platforms are required. Okay, done. Then what we'll do, again we'll move our pointer from here to here, we'll move our pointer from here to here. Now we'll compare, is this value, is greater than this, is greater than this? No, right? That means if a train comes at 11 p.m, so it can't be inserted here, it can't be inserted here. That means we need another platform. That means we'll be incremented by 1, and we'll move our I from here to here. Okay, now I is at here, j is here. Okay, I is here, j is here. Now what we'll do, again we'll compare, again we'll compare, is this j is less than this? Yes, right? Is this j is less than this? Means when when a train comes at 3 p.m, this platform will be empty, this platform will be empty. So what are we gonna do, what are we gonna do, we'll be decrementing. So every time we'll be updating the answer variable. So what is the until then, so till then what is the maximum answer? It is 3, right? It is 3. Now when we see that this j value, that j value is less than I, then what we'll do, we'll decrement this, we'll decrement this platform number. Okay, and we'll move our j pointer from here to here. Okay, j to here, and again we'll see this is less than this. That means again we'll be decrementing, again we'll be decrementing platform number, platform number 1, and move our j pointer. Okay, move our j pointer here, move our j pointer here, right? Now again we'll be comparing. So is 12 less than 15? Yes, right? Then again what we'll do, again we'll decrement our platform, and we'll move our j pointer. So now j is here. Now again we'll compare, is this less than this? No, right? No, right? That means we'll again move our I pointer 1. So this will be I, and we'll be incrementing our platform by 1. Okay, incrementing the platform by 1. Again we'll be comparing this with this, is this less than this? Is this less than this? No, right? Then what we'll do, then what we'll do, again we'll be incrementing our pointer 2, and we'll be moving our I here. So now I is out of bound, right? I is out of bound. So we'll be stop executing, and then whatever the maximum answer we get, so every time we'll be updating this answer with maximum value what we are getting. Okay, every time. So then whatever the maximum answer we get, that will be our, that will be our answer, right? I hope now you have understood the problem. First we'll be sorting this array, this arrival time and departure time. Then what we'll do, we'll take two condition. If departure time is less than arrival time, then then just decrement the platform and increment the j. Otherwise, increment the platform and increment the I pointer. And at every time, what are you gonna do? We're gonna update this answer variable. Okay, we're gonna update this answer variable with max of ans and p. Right? This will how we'll do. So for that, first, what are you gonna do? We're gonna sort this to array, right? So error dot sort. Sorry. Then departure dot sort. Okay. Then we'll take two pointers, right? So I initially will be starting at 1, then j will be starting at 0, and we'll take a variable p initialized with 1, and the answer, okay, it will be also initialized with 1. And then we'll do this thing while I is less than length of this arrival array, and j is also less than this depth. Okay, this depth, although the size of these two things will be same. Okay, so then what we'll do first thing will be checking. So if departure of j is less than arrival of I, okay, then what we'll do, we'll decrement the p, right? P by 1, and we'll move our j pointer by 1. Okay, else what we gonna do, else we'll be incrementing our pointer by 1, and we'll increment our I pointer by 1. Okay, and at last we'll be updating our answer. So answer will be max of this p and ans, right? And at last we'll be returning this answer, this returning this answer. Now let's run the code and let's see. Okay, now for this, maximum output is 3. Here also we get 3. Now try to submit it. Yeah, it is accepted. It is accepted, right? So what else thing you could do, that is one approach. Or another approach could be, if we don't take any answer variable, then what we gonna do, we'll be returning p, but when the departure time is less than arrival time, then what we're gonna do, we not update this p. Instead of this, what are you gonna do, instead of this, what are you gonna do, we're gonna increment the j pointer. Also will be increment the I pointer. Okay, increment the I pointer. That's what we're gonna do. And if we compile this, yeah, it is accepted. Now let's try to submit this. Yeah, it is also accepted. So here what we are doing every time when we get a lower value, so let's compare this with this. So when we when we get it lower value, so we'll not decrement the platform. Rather, what we'll do, we'll put this thing in this platform, and we'll be move our I pointer here and move our j pointer from here to here. Means we are doing two things at same time, right? We are doing two things at same time. So that is also one approach. So I hope now you have understood the problem.